Right, so let's take really quick the problem that we had at lab, I believe 5 point or 4.2, the string manipulation. Let's see the problem number 5. Check if a string contains another substring, right? So let's take this as quickly as possible. Right, so I'm having here this string which is banana, and this is the substring which is ANA, right? Oh, come on. Alright, so let's write some pseudocode or Python code, whatever, on the right, like that. And let's say that I'm going to have, first of all, we have a couple of questions. We have one question and two and three, right? Just gonna have this separated by a little bit of spaces. Now, the first question, do we need a nested loop, right? By this time of the semester, I think you should be comfortable enough to answer and say, yes, you need an nested loop. Because typically, if you have a string and you want to search in it, right? So if you have this string, what would you think of? How would you you would want to make the PC search for that substring inside that string? Well, the easiest option is that when you have some kind of searching that is dependent on, you know, two items or two lists or two strings, this is a nested loop, right? When you have some kind of a sorting algorithm, this is a nested loop, right? I don't want to give you something to be like as if I'm like making you memorize this. I want you to understand it nonetheless, right? So let's say that I'm going to start by having a pointer, which is I, for example, at B, right? And I should have this pointer fixated on that element, right? Because as you're going to see in the third example, this will make sense when we reach the third example. So let's just go with me and say that we are going to have an outer or a counter on the first element of the big string, right? And at the same time, I would want to have a smaller counter or another counter that is on the first element of the substring. Well, now should I make a comparison? Well, yeah, I can say is B is the same as the starting element of the substring. Well, it is not. So there is no point of continuing the check on the substring elements and the check of the second two elements. Remember, we have a three sequence substring. We have a three character substring. So if there is a loop that is going to traverse the substring, then this loop is going to go for 3 times. And if there is some kind of parallelism or parallel comparisons happening in the big string, then this parallel comparison will also goes for 3 times, since this is 3 characters and this is 3 characters. But this is the case where we have a match. If we have a match between one of the elements of these big strings and the starting element of the substring, this is where we will say that the substring is going to go for 3 times, 3 iterations, and as well the string is going to go for another 2 iterations, which is going to sum up to 3 iterations here and 3 iterations here. This is in the case that we have an equality. But if we didn't, then that's it. Then there is no need for me for the big string to check on the other elements, which is B and A. And there is no need for me in the inner or the substring to go and check in an A, right? The first element is what it should be the determiner in this case, right? So as we said, come on. So this element isn't the same as this element, right? So now let's check the other one. So let's see, is B, which is the second element, is the same as the first element of the substring? Well, no, it's not, unfortunately. So now if this is I, and if this is J, and this is J, right? So now let's take the third element of the big string. Is A the same as the first element of the substring, which is J, this is I? Well, in this case, yeah, it's the same. It is exactly the same. So this is a screamer for you to continue and check the J on the next element, right? You want to check the next element of the substring, and as well you want to check the next element of the big string, right? And if there is a match, then continue. We would want to check the J on the third element of the substring, and as well to check the third element of the big string, right? So this is how typically an nested loop would work, right? You are describing typically a nested loop, right? So we need a nested loop in this case. But as you saw something, there's something a little bit fishy here, because remember when we say that we have a loop that has another nested loop inside of it? Remember when we said this, and this for example has a counter of I, and this for example has a counter of J? We said that the outer loop has its counter fixated on a specific element, which in this case A. So how am I saying that? Alright, I understand that the inner loop is going to go through this element and this element of the substring. Right, that's cool. But how is the outer loop is being changed? That's kind of defying what we have been taking so far, right? Like we know that the outer loop should have the counter fixated on a specific element, while the inner loop is being running over the elements of the whatever the list, whatever substring that it has inside, right? So I cannot say that the I, which is in this case at 0 1 2, I cannot say that the I, which is at 2, going to be incremented while this is being incremented, while the inner loop is being incremented. Like I can't say that the I is going to be at 3 and at 4. That's kind of defying what we had been learning so far, that the outer loop should be fixated, right? While the inner loop, which is J, while the inner loop, which is J, is moving. They cannot be moving like at the same time. That's not how nested loop works. It's always like that I is fixated at some element, while J is moving and checking all of the other elements, right? So how come we are comparing this in a parallel fashion? How come when J becomes N, I becomes N as well? And how come when J becomes A, I moves to A as well? We're gonna see this trick in the code in just a minute, right? So this is typically a nested loop. Let's write some skeleton code here, and let's say that I'm going to say, for example, this is let's say that this is going to be a function. It's going to define matching, and this is going to take an S, and it's going to take a substring, right? So the S here is simply standing for the string, which is the bigger string, and the sub is the smaller string. So let me just remove this guy here. And let's say that I have a bit of a loop that is going to traverse the big string for and range. And how many times, this is the second question, how many times should the outer loop work or run? That's something that we are not really sure about, right? Okay, so this is the outer loop, and this is the inner loop for J in range. I know that the inner loop is going to take the substring from 0 to 1 to 3, so it's gonna work as long as there are elements in the substring. Okay, now we should say something. Remember when I was saying that we will check the first element, and we will check an element from the big string, and we will check the first element of the substring, right? If we did not find a match like this case, there's no need to continue the inner loop. If we did not find a match between this and this, there's no need to continue the inner loop, right? So if there's no match between, let's say that this is going to be like that. If there is no match between S, and I'm leaving this empty for a reason, right? Between the current element of the I, or the current element of the big string, which is B or A or whatever, if it's not equal to the element of j, right? If it's not equal to any element of j, right, at any time, maybe you found a matching at a here, and we starting taking j at 0, right? And this is I, which is 2 0 1 2 3 4, right? So what if I have a, okay, there is a match between s of 2, and there is a match between sub of 0. That's cool. This is a and this is a, right? And then we have s of 3, which is in this case n. Then we have n, which is j of 1 as well. So they are the same. But what if I had something here instead of this a at s of 4? What if I had something like k? And this is k, right? So it's basically b, b, a, n, k, n, a, right? So this was k, right? And I'm checking now j of 2. So s of 2, which is basically a. So a is not equal to k. So that's why I put j in this part. So at any point I don't find an equality with that current j that I am holding, then this is a screamer for me to break, right? But before I break, I can use the concept of the flags. If you remember, we did this many times before. So I can just say a flag that is equal to true, assuming that there is going to be a match. There is going to be that substring found inside that string, right? I'm assuming every time I start the loop, I'm assuming every time I start the outer loop at b or at a or at n or whatever, I'm assuming that I will find that substring inside that string, right? If I didn't find, if there was some kind of inequality encountered, I'm just gonna flip that match into false, right? Then I'm going to break. Why would I do this? Because this is going to help you when you break out. This is going to break you out of that inner loop. So when you break out of that inner loop, now you are inside, remember, you are inside the outer loop. Now you can say, if I traversed all of the elements inside the inner loops, meaning that I was at A, and I traversed A with A, and N with N, and A with A. So there was no inequality. So this if statement inside the inner loop never executed, right? This means that the match variable has never been flipped into false, so it is as assumed from the start of the outer loop that it is true. So if it stayed as true, I can just say that there is a match. There found to be a match. There is no inequality, meaning that there was no any different elements, meaning that everything is the same. So we found a match, right? So if we found a match, I can just safely return true. But what will happen if every time I enter the inner loop, I found an inequality, and this if statement executes, and this match becomes false? Well, that's a bummer, but I'm just gonna wait for the inner loop to finish, and I'm just gonna wait for the outer loop to finish, and while everything finishes, I'm just gonna say, there's no if statement needed, I'm just gonna say return false. If everything finished and we didn't execute this return true anytime sooner, we're just going to return false, right? Meaning that there is no matching in that substring or and string, all right? All right. So the question here is that how many times should the outer loop, how many times should the outer loop work, right? And what should we index the s with, this part, right? So what should the string or s be indexed or accessed with? All right. So let's take this really quick. Let's say that this is my iteration 1. This is the outer loop. Okay. I think I don't need all of this space, to be honest. So this is my outer loop, right? And here I is going to start at 0. So let's just say that this is no, that's there are 7 elements. Yeah. So all right, and this is gonna be okay. So I is going to start at index of 0, right? And now, continuing this code here, we're gonna see that the inner loop is going to start immediately. So this is iteration 1 of the inner loop, right? Where j is going to be equal to 0, right? J is going to be here. Now let's see, is that element at index of 0, is it the same as the first element of the substring, right? So is that element which is at index of 0 of the string, is it the same as that element from the substring which is at index of 0? Honestly, that's really obvious here. It's not. That's A, right? And that's B. So it is not. So break. Alright? And remember that we have a match here that is always equal to true. So here, before we break, we are just gonna say that match is gonna be equal to false, right? So we are breaking out of that inner loop and going back to the outer loop, right? So this is the second outer loop iteration. Alright, and this is where I is now at index of 1, right? And this is where j at index of 0. So the inner loop is gonna take place immediately. This is iteration 1 of the inner loop, right? And j is gonna be starting from 0 as well. Okay. Alright, so let's see, is b, which is the second element, the same as the first element of the substring? Well, the substring is starting at 0, which is A, is not the same as the index of the string at 1, which is in this case B. So just set your match to false and just break. I swear my font is better than that, but my screen just dies at this portion of the screen. Okay? So, alright, so we had, just remember, we had a match at the start of every outer loop, like this. So we are breaking. Okay, now we are returning back to the outer loop for a new I, for a new character. So this is iteration 3, outer loop, right? And my matching is starting to be as true. And this is where I is now at index of 2, right? And now immediately I'm going to start the inner loop, right? Like that. So J, as we know, is going to start from the first element, right? And this is I, right? So let's see, is I, which is A in this case, the same as the first element of the substring? Well, in this case, is I, right? This is the substring, which is at index of 0, which is in this case A. Is it the same as the string at index of 2, which is in this case A as well? Well, it is. So we should take another look on the next element of the substring, right? So another iteration will happen, another inner iteration will happen, right? So this is iteration 2, and this is where j is equal to 1. So now this is j, this is j, right? So let's see, is j where it is equal to 1 in this case, right? Substring at 1, which is in this case n. Is it the same as the substring, or is it the same of the string at n? Notice that we need, if there's an equality, it is not only enough to move the inner loops counter, we also need to check in parallel that n. We need to check in parallel that n with that n from the bigger string, right? And remember, the outer loops counter needs to be fixated on I of 2, or else the whole concept of having nested loops is going to break, right? So this is going to be, this needs to be moved, like this needs to be moved on index of 3 somehow. I don't know how, but this needs to be moved at index of 3, right? So now, is s at index of 3 the same as substring at index of 1? Well, in this case, this is n and this is n, so this is an invitation to continue the inner loop, where j should be equal to 2 in this case, right? Okay, so this is j. So sub at 2, which is in this case a, is it the same as, the string at index of 4 without changing the index from position 2, right? So this is what I am checking right now, right? So this is position 4. What is going on? Is it the same? Of course this is the same because this is a, right? So you're gonna find that you have finished the inner loop, right? You have finished the inner loop. The inner loop will work for 3 times, since the length of the substring is 3. So we are going to go 0 and 1 and 2, and we finished 0 and 1 and 2. So I'm going to break out of this inner loop, right, and go check the match. Did we change the match in any of these inner loops? We didn't, right? So when we break out of this inner loop, we are going back outside and check the match. If the match was the same as we assumed at the beginning of every outer loop, if it's the same, it's true, then this is where we return to the user true, saying that we found the match here. Okay, now to answer this, let's answer this question first, right? Now if you look closely, we want to know what should we index this part, like what should we index this part, right? This is typically not going to be I, because if it is I, that's not going to work. Like imagine this is I, so every time it's going to be s of 2, because I is 2. So every time I'm checking if this is A, I'm checking with s of 2, which is in this case A, and if this is n, I'm checking with s of 2, which is A2, which is, if this is A, I'm checking with s of 2, which is A again, right? So this wouldn't work if this was I. So how can we do this kind of parallelism thing, or searching in parallel, without changing the outer loop? If you look closely about the relationships, let's see that for the first, it's not going to be obvious in this or in this. It's going to be obvious in the third iteration, in the third outer loop iteration, when you look specifically at this portion, right? So let's take a look at the indices here. The substring is once was j of 0, so we know that this is for sure, this is j as we settled it here. and we know that for when j was 1, then the sub was at 1, right? So no, I know that this is j. And when j was 2, I know that the sub was at 2, so I still know that this is j. Now the real question is, what is this? This is not only I, right? So I can say without a doubt that I is involved somehow. Like this is partially having I somewhere. It has I. Obviously, it has I, since I is the pointer that is responsible for traversing the big string, right? But maybe it's not only I. Maybe it's maybe plus something, like who knows, right? So this is partially having I. It looks like I in the first inner loops iteration, since I is 2 here and this is 2. But if you look at the next inner loop iteration, where j is equal to 1, you're going to see that this is not typically I. This is not 2. Right? So this is something like 2, which is I, plus something that I'm not really aware of, right? And in the third inner loops iteration, or the last inner loops iteration, you're going to see that the same thing. This is not, obviously, this is not I, which is 2, but this can be something as maybe 2, which is I, plus something, right? And the answer here is really obvious. Like, if you looked at the value of j, you're going to see that j here is equal to 2, right? And this is 4, which is I is 2. If you say plus 2, which is plus j, then voila, you have 4. Let's look at the next iteration here, the iteration before of it. You have j that is equal 1, right? And you know that this 3 has partially I in it, but it's plus something. Well, if we say that it's plus 1, it's going to give you 3. And that one happens to be, surprisingly, the value of j, right? And the same thing goes for the first one, right? So this is seemingly, this is I, but that's not only I, right? So this is something like 2 plus something, which is I plus something. In this case, we can say that this is I plus j, which is j in this iteration is 0. So it's going to give you the same thing as I, right? So we can say that in order to do this trick of fixating the outer loop of I on some element and not changing it at all, and in the same time we do this kind of parallelism between the inner loop continuing to work and move in parallel while the outer loop is seemingly moving, but the outer loop's counter is not actually moving at all. It is just that we are adding a j on every value of I. So we are adding a j on I, and every time that j increases, we just take that j and add it on I. So it looks like the I is moving, but it's typically fixated on a single element here on at 2, right? So this trick, which is I plus j, is going to do the trick for me, right? I'm not going to ruin or screw up the fixated counter at I of 2 or I of whatever, but I'm just going to use the incrementing j to check every element from the bigger string with every element with the smaller string in parallel like this. Alright? Now the last question, how many times should the loop work? If you looked at this, you're going to see that the loop worked for 1, 2, 3. So it seems that this had worked for 3 iterations, but this is the case because we found a match really early, where there was a match at A here, at maybe the third element at index of 2. But what if we had the match at the last element? What if we had the match, for example, what if this wasn't A? This wasn't A, and we have the match starting this, right? So let me just write this really quickly. Let me just make a fictional scenario. If, let's say, I am going to change that A into n banana, and we have A and A, this is the substring, right? So now you would say that the outer loop is going to take that element. Is it the same as this element? Well, it is not. So take the next. Is it the same as this element? At the first element? No, it is not. Now it takes the next. Is it the same as this, the first element here? No, it is not. Now take the next. Is it the same as the first element here? No, it is not. Now take the next one at n equals 4. Is I at a the same as the first element of the substring at j of 0? Well, yes, it is, right? So you can count the number of iterations that the outer loop took in order to reach that similarity. And you're gonna see that this is 1, 2, 3, 4, 5 number of iterations needed, right? Like most of the tricks that involves these kind of things are mathematically can be mathematically concluded. Like if you say that, for example, you have the length here is 7 and the length here is 3, right? If you subtracted these from each other, you're gonna find that you need at least 4 iterations in order to search for that substring inside that bigger string, right? But if we stopped at 4, like imagine we stopped at 4, right? We have only 4 iterations. If we stopped at 4, you wouldn't have the opportunity to find the occurrence of the actual first match of the substring, which in this case, this guy, right? So as a convention, we just add 1 in order to make sure that if the last 3 sequences, if I have something like a 3 sequence of a substring, right, a 3 sequence of a substring, if the last 3 sequences of the whole string were the actual match, I don't want to miss the opportunity to find the first element of that 3 sequences of the big string, right? So we add this kind of 1, right? So if we looked at this, you're going to see that this is the length. 7 is the length of the string, minus 3, which is the length of the substring, plus the 1 that we added for just to make sure that if I have something like Coventry and I'm searching for try, so I just want to make sure that this t will be looked at in the bigger string. I want to have this included with me, right? So that's the whole trick. Another way to look at it is if I did something like this. Let's say that this is all right, and I'm searching for the substring a inside this, right? So you can think about it this way. This is a slice of 3, like this is a slice of 3, right? This substring is a slice of 3, right? So if you want to search for this string, then you are going to slice this string for, you are going to divide this string for 3 slices. Every time you're gonna search for that string, you're gonna search for 3 times. Just let me rephrase this, all right? If you have a substring of slice of 3 elements, right? So you are going to slice that bigger string into slices of 3, meaning that you're gonna start with the first 3. Are they the same? They are not. Okay, let's take the next 3. Are they the same? They're not. Let's take the next 3. They're not. Let's take the next 3. They're not. Let's take the next 3. They are the same. The start is the same, right? So count this. You're gonna see that this is 1, 2, 3, 4, 5. Then you have a total of 5 iterations, which can be achieved within the same exact fashion. If this is 7 elements, right? So 7 minus the slice, which is 3, is gonna give you 4. And make sure to have the last slice of the bigger string. To make sure that this is included with you, you need to include that plus 1, right? Which is gonna give you 5, right? So let's just code this through. Okay, so matching. And take the string and a substring, and this is going to continue for, if we have a sub that is 3 slices, then and I have a string of 7 characters, then I want to make sure that 7 minus 1, which is len minus len substring is going to be traversed +1 to make sure that if the occurrence is at the last couple of sequences of that big string. So let's just make the match here, which is equal to assumingly true for j in range of len of the substring. I'm going to traverse all of the elements in the substring if that current element of the string is not equal to the current element of the substring, then this is a screamer for me to say that I am not finding any matches and I'm breaking. If we went out of the inner loop and there was that a match, or rephrasing this, if the match didn't change, then this is an indication that there is a match, right? There is no inequalities, then just return true. If everything had finished and I never found any matches or matches in the string, I can just return false. So let's say that this is Coventry and this is sub is gonna be equal to try, and we can just say matching pass is pass sub, and this is gonna tell you true. What happens if you remove this guy? It's gonna tell you false. All right.